TweenService is cool, but it's super simple and straightforward. Literally, you give it a start and a goal and it eases straight from A to B. That's it, no stops, no midpoints, and not much control except for a few settings. So that's why in today's video, I'm going to show you guys how to take your animating game to the next level by using runservice. And before I start with the video, if you guys do go on to learn from or enjoy this video, please leave a like and subscribe, but let's get into it. TweenService is nice for creating simple animations like changing a part's position or button animations, but if you ever seen the games with crazy effects and complex movements, they are more than likely using runservice. So what we're going to do is start off with a basic Bezier curve script, and if you guys want to know more about these curves, Bezier curves, then I have an entire video on that. But if you want a simple breakdown on what we're about to do is we are going to have a part move from one position to the next, but it acts as if gravity is acting on it and it's like a projectile. So here I have a part with two attachments and a trail that we're going to use for this system. Alright, so we are going to insert a local script in starter player scripts. And the first thing we're going to do is get runservice, and also we should put this part in maybe, well, we'll leave it out. We're going to use that, and then get our part. So game.workspace waferchild part. And then what we're about to do is create a quadratic Bezier curve. And that basically means that we're going to create a curve with 3 control points. So the start, the middle point, which acts as how we can control the bend or curve of the entire thing, and also the end point. So we need to get those 3 points. And so these points can be defined as P0, and we're going to set this to a new vector, and it's going to be vector3.0, so it starts at the middle of the universe. And then our next point, which we'll call our midpoint, basically we're going to set that to 50 on the y-axis, and then our last point, P2, will be 40 on the x. And so we also need to define a couple variables that will help this come together. And the first one is the duration the animation will take, and we're going to set that as 1 second for right now. And then T, this is going to be the time or the progress along the curve. And so it's basically our elapsed time in the animation. So then the last thing we need is a connection variable, which we will assign to a runservice event because we need this to run every frame for that smooth movement. All right, so let's go down and say connection is equal to runservice.preRender connect function, and then we're going to get delta time, and then we are going to say T is plus equals math.clamp delta time divided by duration 0 or 0 1. So what we are doing here is we are adding delta time divided by our duration to our elapsed time, and then also clamping it between 0 and 1. So if T is greater than or equal to 1, then that's when we know to stop the animation. And we have to divide it by the duration, so it takes in account the duration, so it makes it, more customizable. So now let's just do the check if the animation is done. So T is greater than 1, then we're going to disconnect the connection and then also set it to nil. So now let's get into the formula we are using for this. Now what I'm about to use is taken directly off of Google, and all you got to do is type in quadratic Bezier curve formula. And so I'm going to take what I see, and this is what it is. And so it looks a little bit weird, but that's just because we need to make it so, Roblox knows what we're trying to do. So for example, we're going to get rid of this at the start. And so when we see squared, we're going to replace it with this and times it by P0, and then times P1, and then over here say times P2, and then we also need to put times T here, and then we're going to wrap this in a variable called position, and I believe this is correct. Oh, we have an error here. Oh, we need to say +2 times this, Okay, so here is our position variable. You could do this in a function. It's probably more recommended, but this is what we're rolling with right now. And then the last thing is part.position is equal to the position. So then when you head into your game, you will see that the part starts at the origin, it goes up, and then it goes to its final position. So let's change the midpoint. Let's make it a little bit lower, like 30. So what will happen is the part won't go as high, as you can see. Instead of going like this, it went shorter, and it still reaches its point. So no matter what points you put in here, it will always go to that position, and based off of the midpoint we give it here, so we can say 50, and this is like 140, and it looks really nice. And since this only runs once per game, I think it's a good idea if we put this in a module so we can call it lots and lots of times in our game. So we are going to go ahead and insert a module script and call it Bezier, and then we are going to basically use a lot of this code here, but just put it in some functions and also add a little bit more functionality. Okay guys, so this is our module done. Like I said earlier, almost the same thing as this. We are calling Bezier.new when we want to make a new curve and sending in all of our information, our P0 vector, P1 and P2, and also the duration and the part we want to use. And then also we are adding that elapsed time in here and the connection, and then setting the connection and clamping, adding delta time to our time and clamping it, and then also setting the position from the quadratic Bezier function we made up here. And then once the animation is done, or self.t is greater than or equal to 1, then we're disconnecting everything, setting it to nil. And then I also added a function here, so when you call play, you can supply it with a callback called onComplete. And so if you wanted something to happen at the end when it finishes its path, then it would call the function. And then also if you wanted to stop it for whatever reason, mid animation or something like that, then we also have this stop function that disconnects it and sets it to nil. So then in here we are going to get the modules. So we're going to say Bezier, and then local B, I'm just going to say for Bezier's Bezier.new, and then send in our points. Oh, I should have kept those other points. Okay, so B is equal to Bezier.new, and then P0, P1, P2, and then duration, we're going to say 2 seconds this time, and then our part, so part, and then B, we're going to say play, and then if we wanted to, we could have a function that runs at the end, and then print animation, or done. Well, we're going to say done. Just going to say done. So then go ahead and head into your game. And there we go, there's our part. Takes 2 seconds to reach to the end. And also, when it's done, it should have printed done, just like that. Okay guys, so another cool thing I wanted to show you is a spring motion kind of movement that TweenService can't do. And I know there are spring modules for this, but I'm just going to recreate a little example for this video where the part is going to have a spring movement into a final position. So let's insert a local script and starter player scripts. And to start off, I have this spring function already made, already done, that I found to use for this. And so this is how we're going to be able to achieve the spring movement. We send in the current position, the target position we want, the velocity that we aren't gonna really use for this case, but the stiffness and damping, which is how strong the string, and damping is how much energy is lost. So a few more things we need to get is the run service, and then also a part, the part that's in my workspace. What is happening? Okay, so part, game.workspace, part, and then down here we are going to get a velocity vector. So velocity, we're just going to say vector 3.0 because we're not really going to be using that. And then our target is going to be, all right, we're going to have our part start at 0, 5, 0. So it's going to start there. And then we're going to have the target go to 20 studs, 5, 0. And then we're going to say run service dot pre-render. I think it might work. We'll see how this goes. Pre-render function with our delta time. And then part dot position, comma, velocity be equal to spring, part dot position, and then target velocity, which will be this, and then we need to send in stiffness, stiffness. So we're gonna say 10, and then 0.5, and then delta time. And then also this should be part with a capital P, and then velocity, let's see. We can just say this. There we go. And then I'm also just now realizing I said vector 3, but I didn't say vector 3.new. So I don't know what I'm doing here. There we go. Okay, so if we head into our game, we'll see our part is moving around in a spring. And I can already kind of tell that this 0.5 value is kind of low. So we are definitely gonna have to change that. But as you can see, it keeps going down and down. So let's switch this to maybe 1.5, and we're gonna see how that looks. There you go. That looks pretty nice. Alright guys, so the last thing I'm going to make for this video that TweenService can't do, and what TweenService can't do, is have objects orbit around certain points. So think of this as a planet, and it's just orbiting out in space around the sun, like the spawn location is the sun. So we're going to create that kind of movement. And so once again, local script, and we are going to get run service and our part from the first example, game.workspace wait for child part, and then we are going to say the center, so where it's going to orbit, we're going to say vector 3, and then say 5 right here. So our part will orbit around 0, 5, 0, which will be a little bit above the spawn location. And then we're going to have a radius, which will be equal to 10, and then have an angle, which will keep track of where it is at, so 0, and then run service dot pre-render connect function, get delta time, and then angle plus equals math.rad 90 times delta time, and then local x is equal to math.cosine with the angle times radius. And then the same thing for the z, so copy this. This will go down here, z math.sine, and yeah. Oh, we need to fix that. And then finally, we're going to say part.position equal to the center plus vector 3 dot new x 0 and then z. Okay, so let me talk more about what we are doing here and what all of this means. So here, when we are adding this to angle, we are basically saying that we want the part to move around at 90 degrees per second, because we are sending in 90 here in math.rad. And if you didn't know, delta time, we multiply it by delta time so that the motion stays at the same speed regardless of what FPS you're playing on. And so then for our x and z, x, when we have math.cosine angle, this gives us the x offset. And so as the angle changes from 0 to 2 times pi, which is, a full circle, then that means that this number, this x that we get from this, it basically oscillates from 1 to -1 to 1. And then for the z, it gives us the z offset for the circle. And so when we have sine, it's basically doing almost the same thing. Together, cosine and sine, they trace a perfect circle for this situation. And then we are setting the part's position to the center and then applying our x and z offsets. So then when you head into your game, this is what it looks like. Here we have our part moving around in that perfect circle, and it looks very, very nice. And yeah, guys, this was today's video. If you guys did learn something from this video, or you guys enjoyed this video, please hit the like button and the subscribe button. I will see you guys in the next video. Peace.